So we talked a little bit about ImageNet before, and just again to recap, so ImageNet is very influential in the deep learning community. It really shaped where we are today in terms of convolutional neural networks, and in my opinion is part of the reason why deep learning has exploded in the last couple of years. So just as a reminder, right, it consists of millions of images that were manually labeled throughout thousands of categories. So ILSVRC, it's the ImageNet Large-Scale Visual Recognition Challenge. It's a challenge that was started a few years after ImageNet was launched. And the idea was to distill the categories to 1,000 categories. And there were about 1.2 million images to train on these categories. And the competition was relatively simple. Who can train the model that classifies the most categories accurately? And so these are some words from Yann Lequin. This was actually from a Reddit Ask Me Anything thread. And he says, don't get fooled by people who claim to have a solution to AGI, to artificial general intelligence. Just ask them what error rate they get on MNIST or ImageNet. Right, so this is to say the importance of benchmarking on known data sets. If you claim that your model is better, that's one thing, but really, how much better is it than other models on these similar tasks? We need to compare models in a fair way. So ImageNet and ILSVRC, so the ImageNet competition, paved the way for computer vision research, and again, specifically for deep learning. And the reason that is because it allowed researchers to compare in a very objective way the different algorithms that they were proposing. So again, ILSVRC, a competition with 1,000 categories and 1.2 million images. So in 2011, the leading algorithm was presented here, this XRCE, and this was based mainly on feature engineering. So just so you understand, here we have a linear timeline over the years of the different models that have been suggested, and here we have on the y-axis the top 5 classification error. So this is a metric that was used to evaluate models one against the other, and what you do is, in almost all of these models, they output a probability distribution of all of the 1,000 categories, and you take the top 5 scoring categories. And if the actual object that you were trying to classify is in one of those top 5 categories, that's considered a proper guess, and then we can evaluate the total classification error, top 5 classification error for all these different models, and the one with the lowest score performs best. So we want to minimize the classification error. So again, in 2011, we have a submission, and it scores 26. But really what happens, and it's kind of earth-shattering in the deep learning community, is in 2012. So in 2012, this is considered a very important turning point for deep learning. We have this publication, ImageNet Classification with Deep Convolutional Neural Networks. This is a publication by Alex Kruszewski, Ilya Sutskever, and Jeffrey Hinton, all of them with very illustrious careers afterwards. Jeff Hinton, recipient of the Turing Award. Ilya is currently at OpenAI, and Alex has done all sorts of different stints in all sorts of different companies, and very, very influential paper for the world of deep learning. So let's look at what happened and why we were able to get this sudden jump of almost 10 points different in this classification error.